Hello, everybody, and welcome to SQL Friday number 56. Our guest today is Jeffrey Moden, or Jeff Moden. Some of you have probably read articles with Jeff on SQL Server Central, and some of you may have seen some presentations with Jeff as well. Perhaps on the previous time he was on SQL Friday. I'm very happy that you're a returning guest to SQL Friday, and I really look forward to this presentation, which I think will kind of blow the mind of some people, because there are some best practices out there that I think you're going to kill. So I'm happy to have you here, Jeff.
Thank you very much. Are we ready to rock?
Yeah, you're ready.
Okay. Well, like Magnus said, welcome to SQL Friday, and we'll start this right up. I want to point out that your host is Magnus Alkvist, and without him, SQL Friday would not be possible, and it's amazing that he can put one of these on and find a speaker virtually every Friday, and that's absolutely incredible, and thank you, Magnus, for having me back. We're going to talk about the black arts of index maintenance 1.2. It's called 1.2 because it's actually two presentations rolled into one. There's a whole series of black arts index maintenance that I'm working on, black arts index maintenance presentations that I'm working on. And I've combined 1 and 2 down into about an hour. It's a total of 2.5 hours. Without being shortened a little bit, so I think I got it down to an hour. And what we're going to talk about is GUIDs versus fragmentation, and it's not that simple. We're using GUIDs to just show a principle of fragmentation, and we're actually going to do some incredible stuff. It turns out that the fragmentation for GUIDs, yeah, they're not the problem. We are. My name is Jeff Moden. And here's my email address in the upper right-hand corner and a little bit about me. I am the fellow that coined the term rebar, and that stands for row by agonizing row. And there's a little information here. It is pronounced rebar, like the steel rods hopelessly stuck in cement forever. And I also help make the tally table a household name. And in case you don't know what a tally table is, it's a single column of numbers in a table. And it's used to replace a whole bunch of different types of while loops. It's a little bit of a Swiss Army knife when it comes to T-SQL. I have a starter article out here for you that you can take a look. And in case you haven't noticed, I try to, so far, make my my presentations very, very self. You don't need me if you're watching this presentation. I try to make it so that everything is on the presentation. It also helps the hearing impaired a little bit. Now, SQL Server is not only my profession, but it's almost my hobby, and I do it pretty much to the exclusion of everything else, except maybe breathing and drinking coffee. And so I realize I need to get a life, but I have a face for radio, and you can see that. So the session objectives, there's 3. First of all, we're going to destroy the myth of GUID fragmentation. Why am I picking on GUIDs? Well, the answer is because this is all about index maintenance, and GUIDs are the poster child for fragmentation. And if I can demonstrate to you that we can fix those, we can fix anything. In the end here, we're going to insert millions of rows into a GUID clustered index with less than 1% fragmentation and no index maintenance for months. And no, that's not a misprint. In the process, we are going to lay waste to the best practice index maintenance because we're going to prove that it's not a best practice. It was never meant to be a best practice. We're going to demonstrate the incredible damage that it causes. And yeah, you read that right, it's damage. And we're going to prove also that it's what makes GUIDs fragment. And we're going to also learn a much better way. And putting all of that together, you'll find out that that other way might be applicable to some other indexes that you won't believe. There's also, we're going to demonstrate the simple fix for GUID fragmentation, but there's also a huge amount of other information that we're going to cover. And instead of covering it here, I'm going to speed on and we'll continue trying to get this into an hour. This is also not for rank beginners. We've got a 60-minute time constraint here, and so I have to assume that you know a couple of things about GUIDs index and index maintenance as it is, and SQL Server in general, like what a log file is and what the difference between simple, bulk logged, and full recovery models are. For questions, I promise you, you won't be disappointed. Every time I've given this presentation where people have been, where I stop and let people ask questions, every question, except for one over all the times that I've given it, has had the answer of, okay, great question. That's coming up in the second half of the presentation. So what I'm going to ask is, because we're on a time limit, please hold all questions until the end. I promise you won't be disappointed. And if it's something very, very specific pertaining to the presentation, please reference the page number in the lower left-hand corner. All right, let's talk about the myth of GUID fragmentation. And it is a myth, but let's start with a little word association test. What is your first thought when I say the word GUID? All right, it's a nasty little four-letter word. Did you think of things like all the incredible uses it offers, the incredible insert performance due to no hotspot, the ability to merge multiple sources with no collisions? How about the ability to easily absorb expansive updates? Or did you think of what most people think of? And that would be massive fragmentation. Yeah, a lot of people think about the size of them, but they either the first or second thing that they think about is this massive fragmentation. And even if they can put up with the size, they say don't use it because of the massive fragmentation. Why do we think this? Well, the answer is because there are hundreds of demonstrations that supposedly prove it, and they all look like something like this. On the left, we have some GUID demo code, and on the right, we have some identity demo code. And they create a table, and on the left, they have this one column called a unique identifier, and it's got a default of new ID, in other words, GUID. And on the right, they have an ever-increasing index in the form of an identity column. And in both examples, they make that column the clustered primary key, and then they hum around in the loop for 100,000 times in a very rebar fashion, inserting one row at a time into the tables. And then they show the typical results. On the left, we have code for the GUID fragmentation, and on the right, we have code to check the identity fragmentation. And they both call from sysdmdb index physical stats, and in fact, they're identical in every way except for the table that they're looking at. And then they go to show you the results between these two that prove GUIDs are bad. And so here we have two frames. The top frame is GUIDs. The bottom frame is ints, and the first thing they'll do is they'll whip you over here on the right, and they'll either show you in page count, or if they divide it by 128 like I did, that'll give you the size in megabytes, and they say, look, ints are good, GUIDs are bad, and then they'll whip you over here to average fragmentation in percent, and they'll say, look, look at the sizes here, and again, they'll say ints are good, GUIDs are bad, and if you're lucky, they'll take you over here to average page space used in percent. And again, they'll say, ints are good, GUIDs are bad. And I want to back the old fragmentation truck up here a little bit. If GUIDs are so bad, why isn't this 65% number 50% or less? And the answer is you already know. Partially filled pages will continue to be filled if they aren't trapped short rows, which is part of another presentation. It's the way all GUIDs works. But that should be a strong hint that there's something wrong with this test, and nobody ever looks at it that way. Let's do a little critical thinking here. What's missing from that test? And the answer is reality. It's nothing like real life. They dump 100,000 rows into an empty table, one row at a time, and they expect it not to fragment. How is that different than customer IDs by date? If you're inserting rows from a customer table by date, do you think the customer IDs are going to go in order? No, they're not. And there was no index maintenance. And speaking of index maintenance, look at the size of this table. It's tiny. It turns out to be 474 megabytes, or pages rather, for the GUIDs, and 161 pages for the identity. That doesn't even qualify for index maintenance. This test is terrible for proving GUIDs that fragment. And they don't mention these other types of columns that you're going to have problems with. So there's a little bit more misinformation. For example, what would best practice index maintenance do? And the answer is everything expected, right? It'll reduce the fragmentation to well below 1%. And the GUID index will very quickly fragment again, right? We all know this. We've seen it 1,000 times, right? How is that misinformation? The answer is because they never correctly identify the true cause of the fragmentation. What is that true cause? It's all us, and we're going to prove it. All right, let's do a quick little review on identity versus random GUIDs. And we're going to cover identities first. It's an ever-increasing index, and we have a bunch of pages here. And because it's ever-increasing, all the pages are naturally filled to 100%. That last page is partially filled. And, if we do an insert, it's going to fill up that last page. And if we want to continue an insert, it needs to build a new page and then continue the insert. And if that page fills up, we need to build another page and continue to do an insert. Those pages that have just been added, they're called good page splits because we didn't have to move data from one page to another. The page just magically appeared and started getting filled. I also want to point out for inserts, only the last pages will be in memory. That can be very, very good or very, very bad. And when I say when they will only be in memory, the other pages could be as well, but there's a very strong likelihood that only the last ones here will be. Anyways, this action results in no bad page splits, no fragmentation. And if you look at this, all of these pages continue to be filled to 100% quite naturally. And so there's no index maintenance, and because there's no fragmentation. Random GUIDs, yeah. For inserts, possibly all the pages will be in memory. That can be very, very good or very, very bad. And again, we have our index here, and all these pages are full, for example. If they're all full, and we do inserts or expansive updates, that will result in instant fragmentation and doubling of space. And I say instant tongue-in-cheek because this is relatively a slow process. It takes a long time, like 4 to 43 times longer to build a page than it does to actually just insert into a page. So we have this instant doubling of space used. Now I really want you to start thinking here. Everybody's expecting this. What would make these pages full? Everybody goes, well, duh, Jeff, we're adding data. Yeah, that's true. But what else could make the pages full? And the answer is, could index maintenance make them full? Think about that. Also, if you look at these pages now, they're all half full. What happens if we insert more rows now? Will we actually get any more page splits? Think about it. You'll come to the right conclusion. Some good things about GUIDs. Let's start off comparing index or ever-increasing indexes to GUIDs again. Here's our ever-increasing index. We got these pages full, and the last page is partially full, and there's no fragmentation and no index maintenance, but we have a nasty thing called an insert hotspot, a highly contentious insert hotspot at the end, especially if you're doing a lot of inserts. So I'm going to play what a hotspot looks like, and I'm going to annotate it here with a single word that describes what the end result is. Here we go. You ready? Slow, 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 slow. Each section had to wait its turn to do an insert. Each section had to wait for the good page splits because you can't insert into a page that's in the process of being formed. That could result in some pretty slow OLTP code. And, we've got all these pages full. If somebody were to do an expansive updates on these, the expansive updates would absolutely kill us, just like they do on GUIDs. And it all blocks selects. New sequential ID. A lot of people say, well, you can fix GUIDs by going to new sequential ID. And yeah, no. New sequential ID has this exact same issue. You can actually use random GUIDs in place of identity columns to get rid of fragmentation. We're going to see some of that here. It has no end of index hotspot. and there's no waiting on inserts or updates because there's no contention for one page, and it's also whether expansive updates. There's no page splits. That also means there's no fragmentation. And I know what you're thinking. Wait, what? We are talking about type 4 random GUIDs here, right? And the answer is yes. You know, if we take a look, as long as there's room on a page, an out of order insert or an expansive update won't cause a page split. So here we have our pages, and each one has enough room for one more row. So we could insert rows out of order and there won't be any page splits. Or we could insert a batch all at once in, you know, like one row into each page, and there's a pretty good chance of that because it's all random. No page splits. So think about that some more. All right, let's talk about 3 purposes of index maintenance, and let's do just a quick little review. One of the purposes is to fix logical fragmentation. Unfortunately, this is what people concentrate on. It only matters for sequential read-aheads. In other words, range scans, where you do a seek and then you want to scan many rows like you would do in reporting and things like that. I say frequently, it doesn't matter at all. Usually it doesn't matter at all for OLTP. And that's where, you know, you might be reading one row or inserting one row or whatever. You're going to traverse the index from the root to the leaf level for every single row. And that means you don't, that means you don't have to do any read aheads. And that means logical fragmentation doesn't actually matter. So a totally non-fragmented index and a 99% fragmented index work at exactly the same speed, regardless of what the logical fragmentation is, really, if you're trying to read one row. And that's why for OLTP, it doesn't matter. And it usually doesn't matter at all on SSDs because they just run so fast. The read-aheads work. Now, read-aheads can still slow you down, but not as much as you would think. Logical fragmentation might be the wrong thing to be looking at. Instead, you might want to be looking at physical fragmentation. We should have been doing that all along. The reason, another name for physical fragmentation is page density or page fullness. And if you're at, for example, a 50% page density, that means you're using twice as much memory as you need, your precious buffer memory. So physical fragmentation is probably more important than logical fragmentation, and in my experience it is. And the third reason to do index maintenance is to prevent page splits. And everybody knows this, but a lot of people either forget about it or don't know it. And it prevents so much. You know, if you can prevent page splits, you prevent blocking, log file usage, fragmentation, index maintenance, and you even make things faster because page splits take time. So they're going to block selects. If you block, and you'll see it coming up here, if you block the leaf level, you block all the way up. You can block all the way up to the root level and block out the whole table. So let's see that. Why bad page splits are so bad. And this is actually an introduction to the 2 different types of fragmentation that we're talking about. So first of all, bad page splits. They occur in the middle of the index instead of at the end like we saw, and they have to move data, and that's why they're called bad page splits. They are 43 times tougher on the log file than a good page split. Paul Randall over at SQL Skills has a wonderful presentation on that, or a wonderful article on that. You should go over there and take a look at page split, Paul Randall at SQL Skills. And just to demonstrate, we've got a small index here. This is just the leaf level. It's got 6 pages and they're all full. And they are also doubly linked. And that double linking means that each page remembers or knows where the previous page and the next page is. And this is also the definition of what the logical order of pages is. If, you know, this defines the logical order of all these pages, and if you have the same logical order as the physical order, you have no fragmentation. And that's the goal for doing index maintenance. Now, everybody says, you know what, sort order in SQL Server shouldn't matter when you're doing processing, and I'm going to say, to hell it doesn't. If you insert a row into an index, that row, even if you only have just a clustered index, that row has to live on the correct page according to the sort order of its keys. And in this case, we have a page where we want to insert into page 3, or we have a row that wants to be inserted into page 3. Now, everything is fully logged here, and even this transaction gets logged, and SQL Server says, okay, page 3 incoming. And page 3 says, dude, no, I couldn't eat another bite. And sorry about the bad joke on a Friday, but it is Friday. So SQL Server says, okay, no problem. And it extends the transaction to the next logical page, which in this case is also the next physical page because there's no fragmentation. And then the next thing it's got to do, it's either got to find or build an empty page. And then it has to break this double linking between pages 3 and 4 in this case. That's all fully logged as well. And then we have to create these new links and fully logged. And then it's got to move about half the rows from page 3 to what we'll now call page 3A. All of that is fully logged. And then it finally inserts our new row, which is also logged, fully logged. And it doesn't matter what recovery model you're in, even if you're in the simple recovery model, all of this is fully logged. All right, and we're not done yet. Then, because we added a page down here, we have to update at least the next level up in the B tree, and it may do a page split like this, but that next level up, instead of it just having 3 pages involved, you know, if we have a page density of 400 rows per, or 400 pages per row, we've now blocked 400 pages in the leaf level, and that could continue all the way up to the root of the index. If you block the root, you are blocking the entire table, and you have to trust me, that happens a lot more than what people might think. Okay, none of these pages are released until the transaction commits, and when it does commit, over here on the left we have pages 3, 3A, and 4 make up logical fragmentation because the logical order no longer matches the physical order of the pages, because page 3A is not in, it might even be hundreds, maybe even thousands of pages ahead of where pages 3 and 4 are, so definitely not in order. And then we also have the physical fragmentation, which I just call page density, because pages 3 and 3A are no longer full. So what's the problem with GUID fragmentation here? Well, the answer is we drank the Kool-Aid and we keep using best practices that aren't and never were meant to be. And I'm pretty sure of that, and I'll show that to you for your real quick. Here's what everybody thinks is a best practice. Now, this actually changed on April the 20th, and I'll get to what that change was. But this is what everybody was looking at. And sure enough, between 5 and 30%, they say do an index reorganize, and anything greater than 30% do an index rebuild. And the unfortunate wording that turned this into a worldwide best practice is up here at the top. It says, use the following to determine the best method. Alrighty, best method, best practice, whatever. But like my grandmother used to say, Jeff, we got a little fly poop on our pepper here. Either nobody ever looked at the footnotes, or they took a look at the footnote and decided they wanted to ignore it, because it says these values provide a rough guideline, and that's not a best method, not even close. And they actually say down here, the actual values may vary from case to case. In the cases of index maintenance, what is one case? And the answer is one index. You need to determine what these numbers need to be for every bloody index. That's what needs to happen, and nobody used to do it. They say used to go, okay, I'm just going to do these other things. All right, where did those numbers come from? Here's the link, okay? And the numbers were actually created by a fellow by the name of Paul Randall. You may have heard of him a couple of thousand times. And enough people asked him about where those numbers came from, where he actually wrote an article about where those numbers came from. And one of the things that he says in that article is that, you know, the numbers are made up by him. They're made up based on some good information. But the reason why he had to do that was because Microsoft and his clients kind of held a gun to his head and said, we need a standard practice. And so they came up with that previous page, and everybody used it as a best practice rather than a place to start from. These last two things here, these two paragraphs, these are actually the last two paragraphs from his article, and I'm putting them here because they're super important. And so the second and last paragraph, he says, yeah, those numbers, they're not set in stone. They're a big generalization, and there are a ton of other factors that may affect your choice. And the most important thing is the last sentence, which is also the last paragraph. And he says, in the meantime, take those numbers with a pinch of salt and don't treat them as absolute. Ladies and gentlemen, that's magic decoder ring speak for stop treating them as a best practice. They're not a best practice. Don't use them as a best practice. And the other thing that he says, he wishes Microsoft would update the old white paper on fragmentation. Well, that's where these numbers came from. And on April the 20th of 2021, they indeed updated those numbers. And what they ended up with was this. And this first item here, yeah, that's really good advice. But the rest of it, it's nuts. One of the things that they talk about is, if you can observe rebuilding or measure the specific impact of reorganizing, I got to tell you, reorganizing is a huge problem. That makes this whole thing wrong. Plus, the other thing is, how do you do all this correlation to compare the before and after of what one index is going to do? Never mind all the indexes. They never tell you how to automatically correlate the performance of any of that, especially for all indexes and especially not automatically. A little further proof, if you look at the documentation for SysDMDB index physical stats, which is a really important page that you need to go look at, almost everybody misses this paragraph. It's titled Evaluating Disk Space, and that's probably why everybody misses it. And I'm absolutely convinced that nobody ever reads this. The first part of it is a really, really good thing to read. I'm not going to read it to you here. It's a great intro to fill factor and out of order inserts like goods. So you really need to go and read that. But what's really important is they finally get to the proper definition of what reorganize actually does, and it still evades people. It says alter index reorganize will compact an index by trying to fill pages up to the fill factor, and they left the word up out, and we'll see that. And they'll say, note that alter index reorganize cannot reduce page fullness. Instead, an index rebuild must be performed. We're going to see what that impact is on our DNA here, our indexes. I wrote a stored procedure called index DNA, and that'll be included in the zip file that I send to Magnus. But this is the spreadsheet result of the index DNA. And over on the left, we have page density from 0 to 100%. And if we look at that one little blue cross, yeah, that's one page and it's 63% full. You can tell that just by zipping over here, and you can see, hey, it lines up with about 63% full. And if you look across the bottom, you're going to see the logical page order. These are logical page order numbers. They're not the actual page numbers. And if you have an ever increasing index, time-wise, it'll be from left to right. If it's not ever increasing, there's no guarantee as to what the order of insert is. If you were to drop straight down, you could actually get a page count and divide that by 128, and that'll tell you the approximate size, but you don't need to do that. If we take a look at this legend and we zoom in into the upper right-hand corner a little bit, let's look at things a little bit more closely. Once again, the blue plus there, yeah, that's a single page, and that's for page density. And if you look at this solid blue bar here, it's actually not a solid blue bar. It's a bunch of these pluses very, very, very close together because we've got all these pages close together after a rebuild. If you take a look, we also have a little skinny red line, and it's kind of hard to see here because it's all lined up right now, but there's a skinny little red line embedded in the center of that blue bar, and that's a rolling average of 200 sample points. And then also we have this dotted line, which is a linear trend, and you can see that up here in the in this blue bar as well. All of these will separate in other cases. There's a few more things I want to show you. If you look at this purple line, it actually goes all the way across. It's kind of obfuscated by the blue plus signs, but there's also a purple box here that's hidden, and that's for APD, the average page density, and that translates to what the current size of this particular index is in megabytes. And if you look, we also have TPD, and you can actually see the black line for that going all the way across. That's the target page density, and I typically use that to show what fill factor I want to use. And that gets translated into that target size. And the difference between APD and the TPD, actual page density and target page density, will either show up as a cost or a savings. And so that's pretty cool. Down here in the lower left-hand corner, it will tell you what the sample rate is. In this case, it's 1-to-1. So we are looking at every single page in a million-row GUID table. If it says 1 to 100, then you would be looking at logical pages 1, 101, 201, 301, etc. Again, those are not page numbers. It's just to give you a reference as to what you're seeing on the screen. These are in order by the next page. We also have table and index names that'll show up here, and I have a little bit of a demo for you. And I've already got. Sorry, here it is. Okay, so I'm actually using the demo database from Stack Overflow that Brent Ozar put together. It's the Stack Overflow 2013 database. And what we need to do first is we need to calculate the object ID of whatever table that we're looking at. In this case, I'm looking at the DBO post tables from the Stack Overflow. It's a 32 gigabyte table. And so I'm calculating that and putting it into a variable called object ID. And then to run index DNA, I keep index DNA in master, which is why I pre-named it as SP. It doesn't need to be in the master database. It can be in a single database, but I put it in the master database so I can get easy access to it from any database. So I want to exec SP index DNA and identify the table that I want it to run against. And then the 1 here is whatever the index number is, whatever index number that might be coming from sys.sys indexes. And as you all well know, a 1 is always the clustered index. That's pretty easy. I also have just a little thing down here that shows, yeah, it's actually a 32 gigabyte table, and it is currently defragged. And what I want to do is show you something special. Index DNA returns these two things. It returns this output, which is kind of a header, and this output, which is some data. And it would actually return your actual server name. I just put in add server name here. But if you click on that upper left-hand corner and then do a right click and say copy with headers, and then you go over to, there it is. I also provide a spreadsheet to go along with index DNA. If you notice these two blue cells here, if you go to the first blue cell and select that and paste what we just copied from that index DNA header, it fills everything in nicely, and you can see it filled in the chart with the header name and also the sample date, which is right here, the sample date that we had from index DNA. And if we go over here to the second part and we select it and right click to say copy with headers, and we come back over here to the DNA chart and we click on page, the second blue box, which is page sort, and we do a paste. Ladies and gentlemen, this is what the DBO post database or table clustered index from that actually looks like. And you can see there's a huge amount of pages that are, they've got a lot of free space in them, even after a rebuild. This is a horrible and terrible waste. Now, if you take a look at TPD, it's at 50%. I just want to demonstrate that we can say, All right, I actually want that to be at 97, for example. I want it to rebuild to 97. You can see the black line moved and our red line changed to green line, and it now says, hey, if we can get it to rebuild at 97%, we're going to save 4.5 gigabytes worth of space, but it'll never happen. This index has been reorganized and rebuilt, and it stays like this. What's wrong with this index? The answer is in-row GUIDs, or in-row lobs rather. And that's another presentation that I actually do. These things are called trap short pages, and there's no way that you're going to fix it without doing a couple of tricks. The average page density will be at 83% forever, and this is because of a mistake that Microsoft made in 2005 when they came out with the lobs. All right, getting back to our presentation. This particular index has all the pages at the same fullness after a rebuild, and in actuality, it's a 1 million row GUID, like I said. And what we're going to do is we're going to see what happens when we insert 10,000 rows at a time to simulate daily inserts. And we're going to keep track of things using this table over here in the lower right-hand corner. Right now, excuse me, we're at the start, and as you can see, we have 0% fragmentation roughly, and the page density is actually a little bit higher than our target, and that happens all the time because the way rows are rebuilt. Somebody's got something going on. Can they be muted, please? Thank you. They are again.
Trying to find who it is.
Yeah, everybody hit mute, please. Thank you. Anyways, if you do an index rebuild, it says, okay, does, for example, it'll look and say, will this next row fit on the page? And if the answer is yes, it says, is this page fullness still below the fill factor? And if the answer is yes, then it's going to put that row on the page. And if it's a little bit more than the fill factor, it's going on the page a little bit more than the fill factor. All right, so what I want you to do, we're getting ready to insert some rows. Watch this area above the fill factor for filling up, and watch this area below the fill factor for splits. And on 3, 2, 1, you already saw the preview a little bit. We just inserted 10,000 rows, and all of them went in above the fill factor. No page splits. Let's do another 10,000 rows. Here we go. And again, they went in above the fill factor. This is beautiful. This is what an index should do, right? And we inserted another 10,000 rows, and they went in, and we finally have a page split. And that's why I love this index DNA thing that I made, is because you actually can see what's going on. We had to run it 3 times to see this, but oh my God. And so there's another 10,000 rows that we inserted, and we can see 3 more page splits showed up. And so what I'm going to do is I'm going to run through this in kind of quick now. Here's 50,000 rows total, 60,000 rows total, 70,000 rows total, 80,000 rows, 90,000 rows, 100,000 rows. Okay, so we've been filling up here on the top. We've been watching APD fill up. We've been watching these lines roll up. We've seen all these page splits happen. And we've kind of reached a nice critical point. That critical point is we are now between 5 and 30% fragmentation. This also shows how bogus those other tests were. We inserted 100,000 rows like they did. We only got to 5%, just a little over 5% fragmentation, not 99%. Those other tests are not real life. If you also notice, our page density was increasing, and now all of a sudden it's starting to decrease because we've had a serious increase of page splits. But I also want you to notice the critical area above the fill factor, which prevented the fragmentation before. Yeah, it's now full. And since we are between 5 and 30% logical fragmentation, the best practices say, okay, boys and girls, it's time to do a reorganize. And I go, oh my God, yes, let's go see how well that works. And remember, we're doing a reorganize here. Okay, so there's a couple of things I want you to look at before we reorg. Look at these 3 circles here. They have a page in them. Look at this circle. It has 3 pages in them in a particular pattern. Look at this narrow line just below the fill factor. It's got 2 pages in it. And this other area between the fragmentation area and the fill factor, it is mostly. Hey, folks, please, please, please hit mute. Thank you. Anyways, I want you to watch these, and we're going to do a reorg in 3, 2, 1. Look at that. If you look right here, that used to be filled with 2 pages. It is now chock-a-block full, and our
Sorry, we have lost the screen share, I think.
I'm sorry, what?
No, the screen share is on. You just reconnect to the meeting. It's on.
Okay, thank you. Sorry.
Sorry. Anyways, here we go. The no man's zone got fuller, and the reason why they're getting fuller is because things are moving from this fragmented area, the page split area, closer to the fill factor. And if we look over here at our red or yellow, our red circles, the pages aren't there anymore. They move closer to the fill factor, and the same thing with this other one. It's missing a page. That one page tried to move closer to the fill factor. And so that means that reorganize is actually doing page compression. It fixed the logical fragmentation. Page density increased, but it should have decreased. We still have a ton of low density pages after the reorg. The critical area above the fill factor is not only full, but it actually got fuller. It went from, you can see here, it went from 87 to 88 after the reorg for page density. And I'm sorry, yeah, 88. It still has a ton of low density pages. I'm sorry. The area above the fill factor is still full, and it got fuller. And that's because reorganize cannot make new pages. It compressed the pages up to the fill factor. And I did a separate experiment where I showed even if the area above the fill factor is free, the pages will only go up to the fill factor. So not good. Reorganize will not make any space above the fill factor. And that's kind of critical here because that's what was preventing fragmentation. And to summarize, reorganize removes free space when we need it the most, and that's terrible. We'll show you some of the results here. Here's that same 10-row table with a couple of extra columns, and what does it do during the next 10 iteration? Here's what it does. And as you can see, reorganize gets stuck very, very quickly. In fact, it took 2 days to get to 7% and had to do a reorganize, just 2 days to get to 10%, and then had to do a reorganize, and then it gets stuck. We're at 6.46, 6.47, 6.76, and it looks like fragmentation is going up, and it reaches kind of a peak here, and then, oh, wonder of wonders, it starts going down. Righty, is fragmentation decreasing? Well, kind of, but not really. What is happening is that the number of pages in the table is increasing because we keep adding pages every single day, but we're adding a fixed number of pages. We're only adding 10,000 every single day. And so the percent of pages that we're inserting is a smaller percentage of the table. And that's why it looks like fragmentation is going down. Also, hey, we're going to do something a little different here. Instead of waiting for 2 days of some pretty nasty fragmentation, let's do something a little different, okay? And instead of reorganizing after we go over 5%, let's do a rebuild at greater than 1%. People go, damn, Jeff, we're going to be rebuilding every 15 minutes. No, not true. We actually go 8 days to get to 1% fragmentation now. And the reason why is because we now have space above the fill factor because rebuild did that. And if we take a look over here at reorgs, it compressed and then page splits, and then it compressed again. Well, Okay, how many page splits were there? 1,104. It had to create 1,104 pages for those 2 days. And here's the number of pages it has to create each day. It resulted in building almost 10,000 page builds to do 10 days worth of inserts. And that's not right. If you look over here on the rebuilds, we only had to build 221 pages. And, you know, we went a couple of days, almost 3 days, with no fragmentation whatsoever. And then we did some page splits. And instead of compressing, when we did the rebuild, we did some allocation of new pages. And here we only had 1 page split for 4 days. So 222 total page builds. That is what Reorganize did was 44 times more pages than our rebuilds here. And I want to point out that our rebuilds actually included 12 days, not just 10 days. And so reorg is not looking real good here. And by the way, I call this method of rebuilding at 1% low threshold rebuilds. All right, let's do a longer term little fragmentation study. Let's look at best practices versus low threshold rebuilds across a couple of fill factors for a year. All right, for the test table, it has a GUID column as a unique identifier for a clustered PK, regardless of what kind of test table we have. It has a fluff column of char 100 just to give it some bulk to simulate other columns. And that results in a row length of 123 bytes. We have 16 plus 100 plus a 7-byte row header for 123 bytes. And you can actually calculate the number of pages from that. If you take 8096 divided by that row length, which shows up on SysDMDB index physical stats, that'll give us 65 and change, but we can't have a partial row, so it comes down to 65. And before you go screaming, yes, 8096 is the correct number on this because there's 8192 bytes per page and a 96 byte page header, and that leaves 8096 bytes for the data, the row header, and the slot array. 8060 is something else. That's just the maximum length that they've imparted that they will let you make a row. Alrighty, so we also have some test parameters. I built a 3.65 million row GUID, and I preserved the sort order of that table using an identity column, oddly enough. And so all of our tests will be using exactly the same GUIDs in exactly the same order so that we can see exactly what's going on, except for the baseline. The baseline, yeah, I built another table from the same GUIDs, except I pre-sorted them. And so it's kind of like new sequential ID or even an identity column. There will be no page splits in that. We'll see that. I also do a no index maintenance test, and that's where I do it like everybody else did, except I do it for 3.65 million rows. I just insert 1 row at a time for 3.65 million rows, and we see what happens there. We do some best practice tests as well. We do nothing until we get to greater than 1,000 pages, because that's kind of what the best practice says. And then we do the 5 and 30% thing. If we get over between 5 and 30% logical fragmentation, we do a reorganize. Greater than 30%, we do a rebuild. And I actually did that for these 4 fill factors, both for daily checks of fragmentation and weekly checks of fragmentation. We don't have time to go through all that, so I'll just show you a couple of those. But I also did some low threshold rebuild tests that say, do nothing until we get to greater than 1,000 pages, but then everything changes. If you go over 1%, do a rebuild and never reorganize. And again, I do it for those 4 fill factors for daily and weekly defrag checks. The actual code for all of this testing is we're going to insert 1,000 individual row inserts per simulated hour for 10 simulated hours per day for 365 simulated days, which adds up to 3.65 million rows. And at the beginning of each day, or at the beginning of each run, I set all my stuff to 0, all my counters and measurements to 0. And then we go in here and we insert 1,000 rows in a very rebar fashion. I actually record the duration of that. We're not going to cover that because it's too long for this presentation. What I do want to show you is that after every hour of inserts, I measure and record not only the fragmentation, but the page count and a couple of other things. And I hum around in the loop, and I do that for 10 simulated hours per simulated day. At the end of each day, for our purposes, I measure the fragmentation, say, do we need to defrag? If the answer is no, I just measure how long it took to measure the fragmentation, because that's an expense for us. If we do need to defrag, and I do index maintenance then based on one of the various methods that we want to check. And after that, I count the both the number of entries and the size of what all that represents in the log file. And then we come along the bottom, we bump the counter, and at the beginning of the next day, at hour 0, at the beginning of the next day, I put in all of these measurements that we've sampled for the day for the fragmentation results. All righty, so what that results in is charts that look like this. On the left, we have a page count that goes from 0 to 90,000. Across the bottom, we have the day number. And just in case you're wondering, each vertical line here represents a week. So this is a pretty big chart. And the chart resolution is 1 hour. We record, there's actually 77 plot points per week, because we record 1 at the beginning of each day and then 10 for the duration of the day times 7 days. That's 77 plot points. And of course, the test was simulated for 1 full year. This diagonal line is the baseline. Some facts about the baseline are that it was pre-sorted ever increasing like an identity column, which is also kind of like new sequential ID. It had 0 bad page splits during the run, and virtually 0 fragmentation resulted. And so it didn't do any index maintenance. It needed no index maintenance. Some other baseline facts are, if you look at the slope of this line, except for any vertical lines that you'll see when we do some index maintenance, any line with a slope steeper than this line is due to bad page splits. And you'll see that here in a minute. So speaking of that, here is the no defrag line. This is the test where we just did inserts and we didn't do any index maintenance whatsoever. It has a slope steeper than the baseline, and that's due to bad page splits. A couple of more facts about it. No index maintenance was done, like I said. It resulted in 99% fragmentation, just like everybody else's test almost from the get. And it came up with kind of a natural fill factor of about 68%. And you can see the reason why it's steeper is because it has a constant rate of bad page splits all day, every day. Now, a little bit of information about that page density, because, you know, we defrag to get rid of page density problems. How much is this actually costing us? How much are we wasting in memory and disk space? And most people will go, well, duh, Jeff, take 100 and subtract 68, and you end up with 32, right? No, that's not right. It's actually much worse than that. It actually wastes 46.5% memory because those extra pages that could have been filled, yeah, the free space for that has to be accounted for as well. And so the actual formula is 100, or whatever your target page density is, divided by that page density minus 1 times 100 to turn it into a percent. And here's what we end up with. We are wasting 46.5% of our memory. 46.5% of what? Well, the baseline is 100%. It didn't have any waste. And so if we compare that, yeah, it works out to be about 46.5%. All right, so here comes this nice blue line. This is the best practice with an 80% fill factor. And if your eyes are not deceiving you at this time, it actually is jagged. And the reason why is because it's not only riddled with page splits all day, every day, but it also does a reorg every 3 days. And if we zoom in on this little 3-week section here, we can see the zigzags. In this case, each vertical line is 1 day. And if we move, or if we take a look here, the sudden down sweep, yeah, that's where reorganize was compacting our pages. That's where it was taking away free space. And if we move our baseline up closer so we can compare, look at the angle of these lines. Remember, any line steeper than the baseline is due to bad page splits. And we can see that this whole, if we look at the middle line, the middle, shall we say, the average of this sawtooth, it keeps getting further away from the baseline. And that's because the bad page splits are accumulating. It's getting worse. All right. And if we move our no defrag line, these are even steeper than our no defrag line. Ladies and gentlemen, it's actually better to do no index maintenance than it is to do it wrong. And if we take a look, if we measure just this one area across all these different things for one day, the no defrag line, which is the brown line, 196 page splits. Best practice, 419. The baseline, which is good page splits only, which means if you take 196 minus 156, that says 40 bad page splits. If you have 419 minus 156, that's a lot of bad page splits. And I want to remember you, this is one small index, just one small index. What are your other indexes doing? We got some funny stuff going on in these first 5 weeks. You can see the kind of funny lines moving around. And here's what that looks like. We can see that we followed the same thing as the no index maintenance until we get up to this point, which is 1,000 pages. And then reorgs happen. If you take a look at all these points right here, those are where the reorgs occurred. Everything else, all the other spikes, are where a rebuild occurred. And you might think that looks bad, but it's not. I also want to point out that the reorgs very quickly get stuck. After all the rebuilds, we have these flats. Did we stop inserting data? No, we didn't. We just stopped allocating pages because the rebuilds pre-allocated some pages, and that is a very, very fine feature. Let's do a little comparison here. If we look at this one rebuild here, yeah, that took about a quarter second and about 50,000 log file rows, and people go, damn, that's an awful lot. Rebuilds are terrible, right? No. We went a day and a half with 0 page splits here, and we went out almost 2.5 days just to get to 1% fragmentation. And by the end of the day, you can see it swinging up. It skyrocketed to 7.4%. We had 142 page splits there. And so it wasn't 30%, so we had to do a reorganize. Look at this, more than 2.5 seconds, almost 250,000 log file rows. That's nuts. And what did we get in as a reward? Look at the ramp up here. Look how quickly we did more page splits. We did 420 page splits here, and it only took us 23% fragmentation, but 420 page splits for this one little index. And so that means we're not at 30%. We got to do another reorg. Okay, so we do a reorg. The time comes down a little bit, but we're still talking 250,000 log file rows, and it removed free space. You can see that jag go down. And then what did we get as a reward? 918 page splits for that day. And mercifully, it finally took us over 30%. And we do a rebuild at that point. And you can see the rebuild is still way low, and it's only 50,000 log file rows compared to 250,000. And this time, we went more than a day and a half with 0 page splits. We almost made it to 3 days with 1%. We didn't make it quite to 5% at the end of that third day. We had to wait for the rest of the next day and look at the fragmentation that's happening there. Yeah, we ended up with 293 page splits and 11.5%, and then we get stuck into the reorganize, which is terrible. Alrighty, so now we know what the reason why this line is jagged. This best practice line is jagged. It's riddled with page splits all day, every day, and we know the cause for those page splits now. To summarize, it's reorganized. That's the cause, because it won't clear out the area above the fill factor. It's dangerous. It's kind of like a bad drug. The more you use it, the more you need to use it, and it certainly doesn't work the way like most people think. Not only does it do nothing to prevent fragmentation, it actually causes fragmentation by causing page splits every single day, because it doesn't leave any room for there to not be page splits. It's certainly not a best practice. So how do we fix this? We're going to do the low threshold rebuilds at 1% fragmentation instead. And the politically correct term is friggin' magic. And you're going to see almost all the page splits and fragmentation are going to disappear from our random GUID index. What I want you to do is I want you to remember what the flats are. The flats are very, very important. And so I'm going to replace this best practice line with just a simple dash line to smooth it out. And I'm going to put in the low threshold line. And like I said, it's absolutely magic. Here we go. Look at the flats. 0 page splits for weeks at a time with a random GUID. 0 maintenance for weeks at a time with a random GUID. And if we look at this 3-week section, I don't even need to zoom in. This is the same 3-week section where we were doing a reorganize once every 3 days, and it was riddled with daily page splits because of it. And looky here, we have virtually no page splits. And in fact, we had 1 rebuild, which is what this vertical line is. We allocated pages so that we wouldn't have page splits. We did this predictably, and we went almost 3 weeks with less than 1% fragmentation. And I want to tell you, we have to go all the way back here to get to 1 rebuild every 3 days, and very quickly, 1 rebuild a week. And way up here, this is at the end of the year after a brand new index. Ladies and gentlemen, we inserted 10,000 rows for 32 days. That's 320,000 rows with less than 1% fragmentation. And if we compare the memory here, if you look at the hypotenuse of this triangle, that's where best practices was going. We are using less memory than best practices the whole time. And the only time we come close to having the same amount of memory is when we first do a rebuild. After that, we're stagnant. We're not allocating any pages. The end of run status here, we're going to take a look at the best practice line first, and then we'll take a look at the low threshold line, which was defragged about 4 days before the end. We're going to look at it, what it all looks like right at the end. All righty, this is the best practice. Look at this. Above the fill factor, it is just chock-a-block full. Reorganize can't make new pages, and this is why we're getting page splits all day, every day. And you can see, you know, we've got this magic line at 50%. That's the page split line, and they all split. We got a whole bunch of other things down here at the bottom. Those are kind of what Paul calls skewed page splits. All right, and if we just mark where that ended at, all right, let's add in the low threshold rebuilds at the end of 4 days. Look at this. This has exactly the same number of rows as the best practice did. And it's taking less memory after 4 days, even just after 4 days. That ratio, that difference gets bigger and bigger and bigger. And if you look up here, even after 4 days, we had no fragmentation, and we got plenty of room to grow. And it's actually going to go for about 33 or 34 days because it just keeps getting better. And it had no fragmentation. If you look down here, no page splits after 4 days in the data. It was 0.01%, 7% fragmentation. People go, damn, Jeff, are you blind? We've got these pages down here. Aren't those page splits? The answer is no, they're not. I actually have 12 CPUs, just like there are 12 pages here. Those actually showed up right after the rebuild. Those I have the Developers Edition, which is the same as the Enterprise Edition, which means rebuilds can be multi-threaded. And that's what happened. It used all 12 CPUs to rebuild this. And so there's 12 CPU marks, kind of like the end of index mark that we saw before. There was no increase in page counts. I want to remind you again, this is after 4 days. Just prior to that, we did a rebuild where we had inserted 320,000 rows when there was less than 1% fragmentation. All right, let's look at the other fill factors. Here are the other fill factors. If you have the gifted colored site, the legend will help you here. If you don't have that particular gift, let me just tell everybody else a little bit about this. Most people don't know, but 1 out of 12 men have a color blindness called blue-green color blindness or some other color blindness, but blue-green is the most prevalent. And this is why they end up putting on the wrong color socks, because they can't tell the difference, literally. And 1 out of every 200 women has the same problem. And they're not dysfunctional or anything, they just can't see colors. It's not black and white. You can actually find a website to simulate what they see. But I'm going to help them out here. This short step line is a purple line, and that's the fill factor 90. I don't recommend using a fill factor 90 the first year or even the second year. Wait until after the second year, because all of this is proportional by year. We saw our 80% fill factor. Let's take a look at the 70% fill factor. We went more than 8 weeks of 10,000 rows a day inserts on a random GUID, which adds up to 580,000 rows, more than 500,000 rows, and we had less than 1% fragmentation because we hadn't done a rebuild yet. We were just before a rebuild. Let's see what that looks like over here on index DNA. This is what it looks like, and this tells us a very, very important point. If you look here, again, more than 500,000 rows were inserted, and we have very few page splits. And by the way, all these pages, yeah, they contain 3.65 million rows of data. Very, very few page splits after that 8 weeks. And if you look up here, the fill factor, the area above the fill factor mostly got used. Now, a lot of people will say, well, the fill factor, you're wasting memory. No, you're making an investment. We're using the fill factor to prevent fragmentation. If you stop and think about it, why do you pre-size your log file? And the answer is because you don't want it to expand. You don't want it to take the time for it to expand unexpectedly. So you keep it at a pre-grown size. That's also the reason why you don't shrink it every single day. You want it to stay at a given size. Well, the same holds true with a fill factor. You're making a little bit of an investment and you're getting a huge amount in return, because during those 8 weeks, you had virtually 0 page splits, which meant 0 blocking from this index during inserts. Alrighty, some log file myths. Here we go. And let me check what time it is here. I'm running over. I want to cover these log file myths. This is, and this is really important. I'm sorry I'm going over. On the left here, we have the number of log file lines. Across the bottom, we have the days. And we can see on this red line, that's the best practice log file count, number of rows in the log file. And we can see that after the rebuilds, I'm sorry, I got confused here because I'm in a hurry. These spots where the green arrows are where the rebuilds occurred due to best practices. And you can see after these 3 rebuilds, we started getting flat spots. And the red stuff is the log file count, row counts for reorgs. And if you look here, we didn't do any index maintenance. So this represents how many log file rows we see just due to data. And it just drew a green line across the bottom here. That's the low threshold line. We can see we got rebuilds about once every day, or once a day, very shortly here for the first 12 days. But then we get a decrease in frequency. Just in the first 6 weeks, we're up to 4 days. And so reorgs are not a best practice here. Reorganizes shouldn't be used. And remember, reorganize perpetuated page splits all day, every day. If we look at the first 6 weeks and extend that out to a year, this is what your reorganize looks like, ladies and gentlemen, for the number of lines in the log file. That's a reorg every day, reorg every second day, reorg every third day, reorg every fourth day. And if we look in the upper right-hand corner here at how many log file entries were for that reorg, that's more than 3 million log file entries, folks, for every single reorg. It's just for one index. And remember, reorganize doesn't do anything for you except create page splits. And if you look at this little green line that I just drew down at the bottom, I'll get rid of the reorg line so we can see it a little bit better. That's the low threshold rebuild line. Rebuild every 3 to 6 days, 1 to 2 weeks. And you can start to see the little bumps here from the rebuilds. Yeah, let's talk about this. And remember, between the rebuilds, we were at less than 1% fragmentation. This one rebuild, yeah, it took about 63,000 log file entries. Everybody balks at that and goes, that's horrible. compare that to what we did with the reorg with almost 3 million, took about 1/3 of a second. Let's look at the full recovery model with the 80% fill factor. And again, reorgs are exactly the same because they're always fully logged. And if we look at this rebuild, we can see it's about twice the size of our previous example, 123,000 log file entries. Horror of horrors, right? Yeah, compare that to almost 3 million for the reorgs. And this only occurs once every 5 weeks, look off and the reorgs work. And it took almost a second for an offline rebuild. If we, people want to say, well, what about the space used for that? This is the space used in the log file during that time. The green is still the low threshold rebuilds. You can see it's almost not there. It's in megabytes. And I say almost not there. The rebuild used about 400 and some odd megabytes, but look what the reorgs are using, and the reorgs are doing that every 4th day. It's just crazy. It uses a lot more log file space. Less resourceful or less intensive? No. Reorgs suck. This one is for a full recovery model, same fill factor, and reorgs didn't get any better. We've had a scale change here where, you know, if you look, there's the 3 million line. This reorg, the reorgs get apparently much worse. It took almost 8 million log file entries and almost 9 seconds to run. Everybody goes, horror of horrors. Well, let's do a little comparison. Let's look at the reorgs between these two rebuilds. They took a total of 65 seconds and 22.7 million log file entries. And they ran every 4 days. And I want you to remember, they perpetuated page splits all day, every day. And that's just for one small index. What did the rebuilds do? Yeah, during that time between the rebuilds, we were at less than 1% fragmentation with almost no page splits and no index maintenance, because the index maintenance actually occurs at these spikes. So recommendation, if you can, use bulk logged offline. If you can't, use full recovery model offline. If you don't have the standard edition, you're kind of stuck on that. If you have the enterprise edition, you can use full recovery online, but you can see there's a little bit of extra cost there. Still, whatever you do, I don't care on random goods. Do not use reorganize on random goods. I don't care what you do. It's better to let it go forever without doing any index maintenance than it is to use reorganize on it. All right, there's an exception here for lobs. We'll cover that some other time. But I want to point out other indexes that are fragmenting. Yeah, I would not use reorganize them on a bet. Because you're going to run into the same problem. It's not going to help restore the area above the fill factor, and you're going to perpetuate fragmentation. I want to show you expansive updates here, but we're new sequential ID. I just want to run through this real quick. One of the features is it contains the MAC address, and that's a security risk. That also makes it truly globally unique. There's a whole bunch of other issues. It works like an identity column, massive space splitting. It doesn't solve anything. It's really, really good for merges because of this MAC address if you don't mind the security risk. And it can help prevent some non-clustered index splits, but so can a bunch of other things. So my recommendation for trying to use new sequential ID to resolve fragmentation in goods is don't use it for that. Only use it if you absolutely need a globally unique number because of the MAC address. And also understand that if you're cloning your VMs, it's not going to be globally unique. You have to be careful of that. Recommendation, only use it for collision-free merges. And just a real quick thing on expansive updates. And then I'll let you go. An expansive update is anything that causes a row to grow in size, and these are some typical examples. One of the things you have to worry about nowadays is row compressed numbers, which also come out to be in page compression, because page compression also contains row compression. That makes all of your fixed width numbers suddenly expansive. You know, like if you have an integer, yeah, it's gonna, and it's null, it's gonna be stored as a 1 byte value. If you store a number in there larger than 255, it's going to be a 2 byte value, and that is expansive. And it can be really, really bad. So here we have an ever-increasing clustered index. What most people end up doing is they insert rows, they go in at the end, they process those new rows, then they update those new rows to show that they're processed, and they sometimes update things like a modified by, which is a common mistake. Fragmentation occurs, they lower the fill factor to try to stop it, and here we have a 90,000 row index that was built at 100% that they reduced to 70% to try to stop that type of fragmentation. This is how much space it used to take at 100%. We use 40% more space to build it at 70%. And let's see what happens if we insert just 10,000 rows into this. It looks like the index is going to get shorter, but we're not. It's actually going to have a scale change. And so here we go. Boink. We just inserted those 10,000 rows. What happened here? Well, inserted rows don't follow the fill factor, except for one instance, and we're not covering that here. Instead, they are going to fill up the pages as much as they can, eventually getting to very close to 100%. And it always happens with these append-only index inserts. Now, we just inserted 10,000 rows. Let's turn around and say, okay, we just want to process 333 of those rows and mark them modified by taking the null modified by and putting the stored procedure name in there that modified them. You ready? Here we go. This is what it's going to look like, and you can see it's looking bad, and boom! All but 2 pages of those 10,000 rows that we inserted almost instantly fragmented. This area above the fill factor is not doing anything except wasting space. It will help you justify getting more memory because it's wasting 40% of your memory. And that also means that your range scans, any range scans that you end up doing, they're going to take 40% longer, and you're missing the worst thing of all. What data will the queries concentrate on usually? Yeah, it'll normally concentrate on the most recently added data, and guess what? They are at 50% fullness. And so you are wasting more than half your memory, and so you're taking twice as much memory to run. And that's not going to be fixed until the next index defrag, and it's not going to help you because of the expansive index. And guess what? New sequential ID has the same problem. A properly built and maintained random GUID index, it wouldn't have fragmented like this. It would have grown like you expected it to on this one. And that's already been proven. And so people say random GUIDs have a fragmentation problem. I don't bloody think so. One more thing, Optimized for Sequential Key came out in 2019. It's supposedly the fix for the hotspot at the end. It doesn't fix expansive updates, folks. And worse than that, it's actually a form of throttling. Those were my words, and Pam LaHood, who gave a presentation on this, also said, yeah, that's exactly what it's doing. It's doing throttling. It's slowing things down like red lights on an on-ramp. And she cites a better fix, and 4 of those 6 methods for the better fix recommend changing to non-sequential index keys. Guess what method 4 represents? Surprise! Method 4 recommends using a GUID. But wait, we got this warning down here. Frequent page splits, low page density, and so on. Yeah, we busted that, folks. We now can actually use GUIDs to prevent fragmentation because we know the secret. And guess what? This will also fix the expansive update problem. Now, I'm not going to go through this. I'm going to speed ahead on this review. You can go back and look at that. There's just a whole bunch of things here. But what I want to go to is during the presentation, we use 10,000 rows per day. What happens if we use a whole lot more rows per day on the average? And the answer is pure magic. Do you recognize this chart? Have you ever seen this chart before? And the answer is no, you've never actually seen this chart before. It looks very similar to every chart that you've looked at before, but this one is for 100,000 rows per day. Instead of 90,000 rows per page count, we have 900,000 rows per page count. And if you look, we still have a 32-day period in here because they're all similar, but we're inserting 100,000 rows per day. Ladies and gentlemen, we inserted 3.2 million rows into a random GUID with less than 1% fragmentation. Up here, 80%, we went almost 8 weeks or over 8 weeks, 5.8 million rows with less than 1% fragmentation. And any constant insert rate will create kind of a similar pattern. the pattern will look like this for 10 rows a day. We saw it look like this for 10,000 rows per day. This is 100,000 rows per day. It would look like this for 1,000,000 rows per day because it's all proportional of how many rows you are inserting per day. And so I want to ask you, does anyone in the room still think that random GUIDs are actually a fragmentation problem? I submit to you, no. And stop using what they call best practices. Stop using reorganize. It's killing you. All righty. That's been GUID versus fragmentation. My name is Jeff Moden, and thank you for what you folks do.
Thank you so much. I have seen the presentation before, but even the second time, it's a really good one, and I really like how we back up everything with numbers. So yeah.
You would think I was a lunatic if I didn't back it up with numbers, because everybody knows that best practices are great, right? Well, they've been wrong for 22 years, and so is the notion of GUID fragmentation, because of those. Everybody else was using numbers to try to show GUID's fragmented. So, yeah, thank you. And let me stop sharing here. Yeah, thank you for having me again, and thank you for your comments about you seeing it before and actually enjoying it still.
Yeah. So for everyone, if you haven't read anything by Jeff or heard presentations before, just there is tons of information on the internet. Just Google for Jeff Moden. If you Google for Jeff Moden and tally table, that's probably the first article I read, which was for a string split function that you wrote on SQL Server Central, the 8K string split.
And you did your rebar presentation based on that, that presentation
I did.
a little bit, and that was a good presentation. That's what I ran across that, and that's how I got to meet Magnus Alkvist.
I really appreciate you taking the time to present. I have to run off because my son is home ill, so I have to go home to him. So, but okay. I hope you will be a returning speaker for upcoming seasons, although you're waking up in the middle of the night to do it.
That's okay. And thank you for all you people spending some time with me and for sticking it out to the end. And I'll get the presentation to Magnus along with the index DNA code and spreadsheet, and then you can start to see things for yourself. So thank you very much for hanging around. That means that you folks are also making a difference. And Magnus, you're definitely making a difference. I've seen the kind of speakers that you've been bringing in on these SQL Fridays, and for you to be able to do that on virtually every single Friday, my hat is off to you, good sir. Thank you very much.
Thank you so much.
Remember, Excel's not, Excel's not a database. And I'll let everybody go. Thank you, folks. And I just want to take a look at what do we do in the chat here. And you can stop recording if you want, Magnus. I just want to look at what's in the chat here.
Yeah, I will do that. So everybody have a nice weekend. I'm stopping the recording.